CBS television presents a special report on Sputnik 1, the Soviet space satellite. Douglas Edwards reporting.
Until 2 days ago, that sound had never been heard on this earth. Suddenly, it has become as much a part of 20th century life as the whir of your vacuum cleaner. It's a report from man's farthest frontier, the radio signal transmitted by the Soviet Sputnik, the first man-made satellite as it passed over New York earlier today. One of the places where the progress of the satellite is being watched most closely is the Hayden Planetarium in New York. CBS News correspondent Richard C. Hottelet reports from there now.
Doug, we're in the great dome of the Hayden Planetarium in New York, and I have with me Dr. Kenneth Franklin, an astronomer on the planetarium staff. Dr. Franklin, can you tell us where the Sputnik is now and how it's moving?
Right now it's north of Auckland, New Zealand, and moving southeast. It will be, in 10 minutes, about 1,500 miles north of Little America, and in about 24 minutes it will be over Santiago, Chile, and in about 50 minutes from now it will be over Spain.
Well, it looks as though it'll be missing the United States on this trip.
That's quite correct, it will.
But it does come over here periodically, doesn't it?
It comes over here at least twice a day and maybe more.
Getting back to this track, is it possible that it is transmitting a code, not just a beep signal for radio listening?
Yes, it's quite possible that it's transmitting a code, but we don't realize what the code is, of course.
The initial thrust to get it into the air comes from the lowest and biggest of the rockets in the tandem. When the American satellite is launched, the takeoff power will come from a rocket like this one shown in a recent test. The powerful thrust of the Aerobee sends the whole assembly up through the dense stratosphere, a layer of heavy air 50 miles thick surrounding the Earth. The first rocket is then dropped, its fuel exhausted. A second rocket ignites and takes over. Altitude 140 miles, the satellite being stripped for action. It's that round ball in the nose. Altitude better than 250 miles, and the second rocket burns out, but its momentum carries the whole assembly forward. The second rocket spent, the third and last one takes over, the final thrust that carries the satellite into its chosen orbit. Then all the rocket power gone, but tremendous force has been built up, and the satellite is pushed off on its own at a speed of 18,000 miles an hour. A fixed course circling the Earth beyond the reach of the Earth's gravitational pull. Hundreds of miles in space, the satellite's instruments start collecting data, sending it back in the form of radio signals. A pilotless spaceship, man's advanced scout in outer space.
What kind of information do you want from this satellite? What is it set up to do?
There are hundreds of problems that we'd like to solve with these satellites. Practically every scientist across the United States would like to have his pet problem pursued. No doubt early satellites will investigate temperature of outer space. They will use thermistors in order to do this. These thermistors are very delicate devices which will register very slight changes in temperature. Then also we will have weathermen will put photoelectric cells into some of the satellites, and these will give us some idea of cloud cover all over the Earth in a very short length of time. And then we shall also have the atomic scientists investigating the nature of cosmic particles.
Well, Dr. Newell, what about the vital question that everybody is thinking about? Why and how did the Russians beat us to the draw?